All right, guys, we're on 3.3G, our quadratic / polynomial application part 2. And what we're going to talk about is our height formula using the quadratic. This is a little bit of a physics cross curriculum happening here. So we have the height formula in terms of a quadratic, and h of t equals negative 16t squared plus your initial velocity times t plus your initial height. Okay. In physics, or anyone in physics in here? Anyone taking physics? Nobody is. All right. So, in physics, you may hear this as V sub 0 or V naught, or S sub 0 or S naught. Okay. That's what those are. So, snot. No, that's not S naught. I don't remember what it stands for at this moment, but V sub 0 and S sub 0 is typically what I say. But yeah. So your initial amounts. So what this allows you to do is to create a equation without use of a regression model based on given information. So it says here, you are standing on a bridge over a river holding a rock 36 feet above the water. You toss the rock up with a velocity of 20 feet per second and watch it hit the water. Okay. Write a function. So we're going to write the function using this format. Does that make sense? Yes. Okay. So in the problem, it gives us everything we need, right? The 36 represents our what? Our initial height. So the 36 is our initial height. So this right here is our S sub 0. And the 20 feet per second is our what? Our initial velocity, our V sub 0. Agreed? So I'm going to plug these in where they go and create my function. So we have h of t equals negative 16t plus 20t plus 36.
Yeah, 16.
Oh, I squared. Thank you. Was that terrible?
Yeah.
It was so horrible. I know. My bad.
I can't do it.
Okay, so now we're going to graph the function over a reasonable domain. So our reasonable domain here is going to come from what is going to take for our function to be in quadrant 1, because this is a real world situation, right? All right, so from here, we know that initial, so at 0, we are at 36. Does that make sense? And we know that it's going to go up and then it's going to come back down at some point. So our graph is going to be like, some point you're going to go up and then you're going to have to hit the water at something, right?
Yeah.
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 Okay, so now we're going to graph to find at what point is it the highest and when does it hit the ground. So let's go graph it. So I'm going to go to my Desmos. I'm going to clear out what I already have in here from our do now. And I'm going to reset my graph also. All right. So we're graphing our negative 16x squared.
If we give t, right?
Yes, it's only formatted in x and y.
Okay.
And we're going to put plus 20x 20x plus 36. All right, so here we are. I got to adjust it because I can't really see anything. So I'm going to do a quick adjustment here with the tool instead of practicing with the zoom. You can play with the zoom if you want. I know that my x is pretty small, so I'm going to bring it down to 4. And my y, well, if I'm already at 36, I'm going to have to be higher than that. So I'm going to see what about getting to 60. And now I have a better window for my graph. Does that make sense? How you adjust is up to you. So don't depend on my adjustments. You can change your numbers. The goal is just to be able to see your full graph. Okay, so we knew that our initial was at 36. And we need to know, when did we reach our highest and when did we come back down?
You read your highest
We're at 0.625, 625,000 and 42. Yep. So now we can finish labeling everything. and we were at 42. And then we came back down. Okay, so now we have established what's taking place in quadrant 1. So what is the domain here? Your domain or your x value, so what? So
It would be 0.62 or 0.65 and then 0.2.
okay, it's just 0. We start at 0 and we end where? And then our range is what?
30, no, 2.
Our lowest y value is
2.2.
0 to
all the way.
2.25.
There we go. Okay. All right, now it's asking us, when will the rock hit the water? Well, when does the rock hit the water? So at 2.25 seconds. Then it says, what is the maximum height of our rock? There we go. And then it says, when will rock reach its maximum height? So how long did it take me to get to my maximum height?
0.625 seconds.
And bam. How do we feel?
Not bad.
Not terrible with height formula?
No.
All right. All right, so suppose you release the rock and let it fall. Well, that means that we have no additional velocity working with us. So our initial velocity here is going to be 0. So what does our equation look like? So now we're at h of t equals -16 t squared, but there's nothing in the middle, but our initial height is still what? Still at 36. So plus 36. Yeah? All right, so now how does that graph change? So let's go look and see. So we're taking out.
On the top of parabola is just on the line.
So your highest point is where it was, right? This is now our highest. And now how long it takes it to fall?
1.5.
1.5. So we were here and we just go, pretend there's a little curve to that. It's the most curve that's going to happen out of me, I think. Let's try it again. There's better. So we were here at 36, and then where did it fall?
So 1.5,
Okay. So now what is the domain in this quadrant? 0 to 1.5.
0 to 1.5.
And what's our range?
0
0
to
to 32.
0 to 36. So when will the rock hit the water? 1.5 seconds. And what's the maximum height? 36, where we were standing, right? And when will the rock hit its maximum height? Well,
0 seconds.
0 seconds. Because all I did was like, pew. I didn't even give it a chance to make a little curve or do anything, right?
Yeah.
All right. Still with me? All right. So now we are still throwing the initial velocity, but we're throwing it toward the water. So we're going to just be standing. Our height where we're at doesn't matter. We're just going to go whoosh, throwing it. So what does that function look like?
-16 squared plus 42.
Plus 20t. So now we're saying that our initial height doesn't matter, which is going to make it 0.
So why did we write the h of t with our initial height? Doesn't matter.
It's still the height formula. It's still that's just what the function is called. So when did the rock hit the ground now? Oh, I put a T, my bad. So now we're doing this, right? So we're at 1.25 seconds.
Everybody likes it.
All right, yes, so how do we fill out height and velocity in terms of a polynomial application?
I mean, it's pretty simple.
Okay. Well, when you get to physics, you will dive deeper into this.
Fine.